Okay, in this video, I'm going to go over the last two examples in section 8.3 dealing with testing a claim about a population mean. Didn't get a chance to cover these in class, but pretty much if you're able to do those first four examples, then this should be enough to complete these two as well as the homework for section 8.3 in my MATLAB. In example 5, it states this: a simple random sample of 10 pages from a dictionary is obtained. The number of words defined on those pages are found, with the results being n is equal to 10, x bar is equal to 65.8 words, and s being 15.7 words. X bar is your standard deviation, which is 65.8, and your standard deviation s is going to be 15.7 for that sample. Given that this dictionary has 1,425 pages with defined words, the claim that there are more than 70,000 defined words is equivalent to the claim that the mean number of words per page is greater than 49.1 words. Use a 0.10 significance level to test a claim that the mean number of words per page is greater than 49.1 words. What does the result suggest about the claim that there are more than 70,000 defined words? Here you're to identify the null and alternative hypothesis, test statistic p-value, and state the final conclusion that addresses the original claim. Assume that the population is normally distributed. So pretty much one of the requirements is that it is a normal distribution. The population is normally distributed, so that's one of the requirements. And we have a simple random sample, so that's the other requirement that's being met. So that means we can test a claim about a population mean. And we can follow that 8-step procedure. So like in step number 1, let's first identify the original claim. All right, now the original claim has to be written in symbolic form. So here we're testing the claim that the mean number of words per page is greater than 49.1 words. So we're dealing with the mean in this case. So that's going to be your Greek letter mu. Is greater than is this symbol, than 49.1. So mu is greater than 49.1. Now, step number 2. I want the opposite of the original claim. Well, the opposite of greater than is less than or equal to. So that means mu is less than or equal to 49.1. Okay, that's step number 2, right there, the opposite of the original claim. Step number 3 is writing the null and the alternative hypothesis. Well, let's find out which one would be our alternative hypothesis, because it has either not equal to, less than, or greater than, and it will have to be this original claim. Mu is greater than 49.1, which is also the claim, as I mentioned. The null hypothesis always has the equal to in it regardless, so it'll be mu is equal to 49.1. So that's step number 3. Now, step number 4 is the level of significance, or the alpha level. Excuse me. The alpha level is indicated in the problem. Use a 0.10 significance level. So alpha will have to be 0.10. Now, step number 5 and step number 6, we're going to use technology. So here, this will be from the TI-84 plus calculator. This we're going to find out what our t-test statistic is. Now we do have our summary statistics right there. We do have n being equal to 10 given to us, x bar, which is the sample mean, 65.8, and s, which is your sample standard deviation, 15.7. Okay, so now we're going to use that procedure that I gave you in class to do this, to enter this in the calculator. And here was that procedure that I gave you, the handout. Press your stat and then select test. Select t-test in the menu and then press enter. You'll enter your claimed value of the population mean, which is mu sub 0. Since we're using summary statistics, we're going to select stat. We want to make sure that's highlighted, then press enter. Enter the sample mean, which is your x bar. The sample standard deviation, that's going to be S sub x. Your sample size, which is n. Then step number 5 is for mu. You're going to select the format used for the alternative hypothesis, and then select calculate and press enter. So here's what we'll do here. Okay, so using my calculator, we're going to press the stat key. Go to test using your right arrow key. We select number 2 since this is a t-test. We're dealing with a t-test here. Press enter. Stats needs to be highlighted. If data was highlighted, you need to put the cursor on top of the word stats. Press enter to make it bold. And then mu sub 0 is coming from that null hypothesis right here, which is in this case 49.1. So we type in 49.1 and then hit enter. And now we can enter the mean, which is your x bar that's given to us as 65.8. Type that in, press enter. S sub x is your standard deviation, that's lowercase s here, that's 15.7. Type that in, hit enter. N is 10. And then for the mu, we're either going to use mu is not equal to 0, not equal to mu sub 0, or less than mu sub 0, or greater than mu sub 0. We have to look at the alternative hypothesis. That's going to tell us which one to select. In this case, we need to select greater than our claimed value of 49.1. So we put the cursor on top of that greater than mu sub 0 and then hit enter. Then use your down arrow key to go to calculate and then press enter. So here's your t-test statistic right here. And if we were to round this off to 2 decimal places, it would be approximately 3.36. So our t-test statistic is 3.36. That's step number 5. Step number 6 will also come from the TI-84 plus calculator. Step 6 is going to be the p-value because it did ask for the p-value. So we're using the p-value approach. And here it is. Under T is P, lowercase p, that's your p-value. So the 3 decimal places, this will be 0.004. Okay, that's step number 6. Step number 7 is your decision rule for the p-value. So here you're comparing the p-value with your level of significance, which is alpha. And it states that the p-value is less than or equal to alpha, you want to reject the null hypothesis. And in this case, your p-value was 0.004. Your level of significance alpha, that's given in step number 4 as 0.10. And then we ask ourselves, is 0.004 less than or greater than 0.10? And in this case, it is less than. So it does satisfy the decision rule. So that means I can reject the null hypothesis. Reject HO, the null hypothesis. Well, think about this. The claim was the alternative hypothesis. We're rejecting this null hypothesis, so that means we are supporting the null hypothesis or supporting the claim. So step number 8 is our conclusion using simple, non-technical terms would be this. There is sufficient evidence, and I'll go ahead and write it out, and you will be expected to write it out on your exams as well. There is sufficient evidence to support the claim that the mean number of words per page is greater than 49.1 words. Okay. All right, so that's pretty much that 8-step procedure for testing a claim in this example 5. Okay. And example 6 is this. States here, a data set about speed dating includes like ratings of male dates made by female dates. The summary statistics are given here. N is your sample size, that's 196. X bar, the sample mean, is 7.81. Standard deviation of the sample, S, which is 2.25. Use a 0.05 significance level to test a claim that the population mean of such ratings is less than 8.00. You're assuming that a simple random sample has been selected, and identify the null and alternative hypothesis. Test the test statistic, p-value, and state the final conclusion that addresses the original claim. So we already know that those two conditions are satisfied. Our sample size n is bigger than 30, and we have a simple random sample. We're assuming that a simple random sample has been selected. So we can conduct a hypothesis testing procedure. Starting with step number 1, we need to identify the original claim and write it in symbolic form. Well, the claim is that the population mean of such ratings is less than 8.00, and we're testing a claim about a mean, so we must use the Greek letter mu. It's all about reading the problem. Is less than 8.00, so we have to use the less than symbol, 8.00. Step number 2, the opposite of the original claim. Well, the opposite of less than will have to be greater than or equal to. So the mu is greater than or equal to 8.00. And then step number 3 is writing the null and the alternative hypothesis here. Well, for the alternative hypothesis, that original claim has strictly less than, so that must be your alternative hypothesis. So its mu is less than 8.00. And I'll identify that as a claim because the null hypothesis must have the equal to sign. So it'd be mu is equal to 8.00 for your null hypothesis. All right, so that's step number 3. Step number 4 is your level of significance. Well, that's given to you in the problem. You're to use a 0.05 significance level. So that right there was just step 4. Now step number 5, of course, we can use our graphing calculator to do this. So here we have our summary statistics where the sample size n is 196. The sample mean, which is x bar, that's 7.81. And S, which is your sample standard deviation, that's 2.25. So from the TI 84 plus calculator, let's get our t-test statistic. So here we're going to press the stat key, right arrow over to test. We select number 2, which is your t-test. Stats needs to be highlighted, which it is. And then for mu sub 0, that's going to come from the null hypothesis, which is, of course, 8.00. Then hit enter. X bar, which is your mean, sample mean, 7.81. Enter. S sub x is the sample standard deviation, that's 2.25. And in this case here, your n is 196, that's your sample size. Now for the mu, that's going to come from this alternative hypothesis here, because you have to use either less than, greater than, or not equal to. In this case, our null alternative hypothesis says mu is less than, so we need to highlight the one that says less than mu sub 0. So here we'll put the cursor on top of the less than mu sub 0 and then press enter to make sure that it's highlighted. All right, and then go down, use the down arrow key to go to calculate, and then press enter. And you see what your t-test statistic is for this sample data, which is to 2 decimal places negative 1.18. That's your t-test statistic, negative 1.18. Now, step number 6 is going to come from the TI 84 plus calculator as well, because here we want the p-value. Since they asked for the p-value in the directions here, we can get that from right here. Underneath t is the p-value. Here's p. Let's take the 3 decimal places. That's going to be 0.119. If we were to round to 3 decimal places. So 0.119 would be your p-value. And then step number 7 is our decision rule. Since we're using the p-value method, we're going to, excuse me, say this. If our p-value is less than or equal to alpha, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. So if we compare 0.119 with our level of significance of 0.05, you can see here that 0.119 is greater than 0.05. So here, this does not satisfy the decision rule, so that means we must fail to reject the null hypothesis. Fail to reject the null hypothesis. And if we fail to reject the null hypothesis here, step number 8 is our final conclusion written using non-technical terms. Let's see here. The claim was the alternative hypothesis, but we failed to reject the null hypothesis. So that means we don't have sufficient evidence to support that claim. So there is not sufficient evidence to support the claim that the population mean of such ratings is less than 8.00. And I'm taking that from the statement up here where we're testing the claim about the population mean of such ratings is less than 8.00. Okay, so this should be enough to help you complete the homework problems in section 8.4. Reach out to me if you have any questions about any of the homework in my math lab.